This video is an introduction to number systems. The aim is going to be to go from how we do counting to introduce the number system format that we'll use when we look at things like binary systems. So if we want to start, just think about how do we count to pick a number, say 13. What will we say? 1, 2, we just keep adding 1 to it, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So pretty easy, always adding 1 to the previous one. But notice when we went from 9 to 10, we went from one place or one digit to 2 digits. Well, if we can think about initially, there would have been a 0 here. We can see that there's a group of different symbols that we have here. And as we build up to this number, when we get back to the next 0, we add 1 onto our digit and we start back over at the start. So think of these as different symbols for the number system. And by the time we got to 13, we had 2 digits. Well, we can use that same idea to look at how do we do other forms of counting. So this is going to be called base 10. We'll look at a different example that's a little bit different. If we consider using our hands to count, how high can we count to on just the 2 hands? Just make some simple assumptions. Everyone has 5 fingers or 4 fingers and a thumb to be specific. And you can't just remember. So you can't say 1, 2, 3, 4, 5 and then hold up your other hand to say, okay, I'm remembering 5. You have to be able to quickly show any number. Well, using this same idea, if we change our number of symbols from, on our first example here, we had 10 different symbols. Let's think about it for our hands. If you have a closed fist, that might be 0. And at 1 finger up, 2, 3, etc., that'll give us 6 symbols. So with those 6 symbols, we can get it as high as 35. And we'll show an example in a second. We'll show the format as well on how we can achieve this. So just to show quickly, how do we do that? We say, if we start, we consider our initial hand, think of this as our ones place to be 0, and think of this as, if it was base 10, to be our tens place. So we'll start from 0, build up to 5. When we add 1 more, this will change. This will reset to 0. You could also think of this as like the odometer of a car. So these will be the numbers that we're used to seeing, and this is just going to be representing the number of fingers that are up on each side. And this would be a base 6 because we have 6 symbols. So 0, 1, there's 1 finger up. 2, 3, doesn't get interesting until we go from 5 to 6. So when we transition from 5 to 6, this hand should go up and this hand will reset. This will look like 6, but this will look like 1, 0, because it's just tracking the number of fingers that are up, or the number of symbols. So we get that pattern where we're starting to cycle across. If we jump through more of them, we just keep applying that same pattern in the ones place. This time, we'll go to 2 and 0, which now means 12. Now one thing to notice here is, well, 12 is just 2 times 6. And 0, well, 0, 0. But if we look at, say, 13, you could think of this as 1 times 6 raised to the power of 0. So 6 to the power of 0 is 1. So we have 12 plus 1. We add them together and we get 13. Keep that in your mind for as we progress. Work through some more. It transfers to 3 and 0, etc. So the biggest number we can get to is 35, which in base 6 would look like 5 and 5. If we wanted to add 1 more, we would need a third hand over here somewhere. That would become 1, and then these would reset, and we could build that up in groups of 35, etc. So you can think of these as our digits, and we can exploit the format from there. So going back to our blackboard, those were the first two digits here, and they could have the numbers 0 to 5. Now what we did there was, recall when I said we had 13, and I said, well, that's 2 times 6, and it was 1, but that was 6 to the 0, and this was 6 to the 1. All we're doing here is we're tracking the digit where it belongs in the number, and we start at 0 so that we can always have this counting as our ones place. This is the same as you would have learned in elementary school at some time. Let's take the number 123. Well, we can break that up so that it's 100 plus 20 plus 3. And that's the same as 1 times 10 squared plus 2 times 10 to the 1 plus 3 times 10 to the 0. We're just exploiting that positioning information. So if you think of the digits as being numbered 0, 1, 2, then that's where those numbers are coming from. And the 0 over there. Depending on what numbers we use for our symbols, that will affect what we call the base or the radix of the number system. So in this case, that's base 10. Because we have 10 available symbols, it only goes up to 9. And this one is base 6 because we have 6 available symbols. One thing that you could also notice, add 1 to 9 and we get 10. Add 1 to 5 in this case and we get 1, 0, which is a representation for 6. So whatever the base is, whenever you add whenever you are able to represent the number for that base, that's the first time that you'll have moved to 2 digits. So that's how we can go from basic counting to number systems. And if we want to look at terms, our base would be the quantity of symbols that are required to represent something. A term that you may see is exponentiation. And that just means when we raise our base to a particular power, and symbols, of course, is the quantities that we have there. One thing to think about for symbols is if it makes sense in the context. So if I said, take a base 6 number, and we're going to say 1, 2, 3. Well, if we use the same format, then that's going to be 1 times 6. Let's look at the positions. You can number it from right to left, or when the quantity of digits is small, left to right, it's also easy. So this 2 is this 2 here. 2 times 6 to the 1 plus 3 times 6 is 0. 6 squared is 36. 6 to the 1 is 6. 6 times 2 is 12. And 6 to the 0 is 1, so we have 3. 36 and 12 is 48. 48 plus 3 is 51. Now, what if we had the number in base 6? Now we have a problem. This symbol doesn't make any sense in terms of base 6. It would be like saying, as you're used to counting in base 10, I want you to count to 1, 2x. Well, if you looked at that x, it would be, I don't know what you mean. that the symbol x has no meaning in our base 10 system. Well, it's the same way for base 6. 7 is above the highest symbol that we can represent, which is only 0 to 5 here, so we have a problem. That's not symbols that are recognizable in base 6. What about this? Same problem. 6 itself isn't a number that we can recognize. So that's an introduction to using number systems and counting. We'll look at how that relates to binary in a future video, and then we'll try to relate on how we do conversion between them. That ends the initial video on number systems.